So when we're looking at this, your sample space so we're dealing with the set of all possible outcomes or results of an experiment. So possible outcomes of that particular event that we're talking about. So if the experiment is to select a number between 1 and 4, the sample space would be 1, 2, 3, 4. Again, we'll be using set notation to identify each of these pieces. So if we flip a coin for A, you can either get heads or tails. We can denote heads with an H, tails with a T. If we're just flipping one coin, then there's only 2 outcomes here. If we flip a coin 10 times and count the number of heads that come out in those 10 times, we could have the possibility that there's no heads. In other words, they're all tails. That's a 0. It just marked through it. All the way up to ten, all of them are heads. Those are the possible outcomes, how many of them there are. So you roll a 6-sided die and note the number that is on top. What would be the outcomes there? 1 through 6. Now if we roll 2 of them and we want the sum, what is the smallest sum we can come up with on that one? 2. All the way up to? All right, take a look at the ones for your turn. See what you get. So if you're identifying the sample space, you are listing out the outcomes, all possible outcomes. So on the first one, you can either draw the images of the suits. So draw an image of a heart, a club, a spade, a diamond, or list them out. Either way. Any of those are fine. So you either say them, list the names of them, or draw the images of each of them. That's fine. You draw a card from a standard deck and note its rank. So now we're talking about what number or type of card it is. We have ace, all the way to jack, queen, and king. The last one's a king. It's weird. You roll a four-sided die and note the number on the bottom, because obviously it can't have a number at the top with it being a pyramid. So again, there's only 4 options, because it's only got 4 sides. But now if we talk about the sum of 3 of them, what is the lowest sum? So the lowest sum would be 3. All the way up to 12. Questions? Again, today is just going to be listing out your components. Okay, so multi-stage experiments would be when you roll 2 die or you pick 2 cards. Okay. So, either in succession or simultaneously. In other words, you are rolling 2 die, you throw them out at the same time, that happens at the same time. In succession, usually those are ones that the second one depends on what happens first. Okay? So if we are looking at independent experiments, one, that means each stage has no effect on the other. Okay? Dependent means at least one outcome affects another. Okay. So if you flip a coin and note the result, then flip the second coin, flip the coin again and note the result. They're completely independent of each other. The second coin flip does not depend on the first one. So this one would be independent. However, this next one is dependent. You draw 2 cards from a standard deck, one at a time. So if you draw the first card, then the second card you have the option of getting depends on what you do the first time, because now you can't get that card. Okay. If we said with replacement, meaning we're going to put that card back in the deck when we draw the second time, now it's independent. Because you have the same 52 cards both times. Okay? So if you see that with replacement, it means it goes back in, and it's now an independent event. So, you can take a look at this next one. You can change it to shirts and pants. It does not matter to me. But you're getting dressed. You've curated your wardrobe such that you are comfortable wearing any sets of pants with any sets of shirts. Whether it matches or not, you really don't care. Just whatever you pull out of the closet that is hopefully clean, you're going to wear. On question 6, you're going to get a little bit picky about what you're wearing. It's got to match. So, at number 5, independent or dependent? Independent. And then number 6, what is that one? Dependent. All right. So, using tables to identify sample spaces. This is something you can use to help organize your information in order then to fill it out. The whole list of the sample space. So when you're doing this with the way this one is organized, we've got our 6-sided rule on the rows and the 4-sided rule on the columns. So when you list these, you list the row first. So it's going to be 1, 1, 1, 2, 1, 3, 1, 4. So that means I rolled a 1 from the 6-sided die and a 1 from the 4. A 1 from the 6 sides and a 2 from the 4. So again, row is first. And so we just completely list these out if you're organizing it by table. Okay, so then the goal of having that table is then to see all the possibilities. So then you can list the set of the sample space. I'm not going to make you list that because that would be very tedious to list it all again. So again, identify the sample spaces, what that means is we would actually list of each outcome from the table. So if you are actually listing the sample space of this, you would list all 24 of those combinations there. Okay? We're not going to do that. 'Cause I don't want this to work. All right, so now the other piece. When we get involved in things like this, where we've got words that we are identifying, you want to be very careful using one letter to identify each thing. So, vanilla, chocolate, rocky road. If two of your words start with the same letter, then it's use maybe a subscript. So there's two R words or two R words, R and a subscript R and a subscript of what the other one is. Okay. So again, we don't really have to worry about this too much because all of these start with different things. Because if you see 3 letters listed as an outcome, then that indicates that there are 3 things you put together. Okay, so again, if I wanted to use 2 letters here, use a little subscript on that W for whipped cream. But since all the letters are different, I would just use the first letter of each one. Okay, so this list isn't too bad to actually list the sample space. It doesn't matter. So for me, I'm listing all the vanilla options, then all the chocolate options, then all the rocky road options. You could list all of the fudge options, the whipped cream options. As long as all 9 options are there, you're fine. There's no particular order that these have to be in. Okay. So again, listing your sample space. Table is just something that gives you a way to organize the information that's coming in. It's not necessarily something that's required or needed, but it is a way to keep things organized. See what you can do with the Punnett square. Again, listing the row first. So we are listing what are possible outcomes. If the sample space is listing all outcomes, then we have 4 outcomes. Okay. So it's something to keep in mind as we're doing these. All right, so make the table and look at the information for number so we have heads, tails, so do they identify which one happens first? No. So if you put the dice roll on this, as long as you've identified what you're doing first, it's fine. So again, identifying row first, then column. And then listing the sample space out. So then we've got so all the way up to 6 for each. All right, so that works if you only have 2 events and they're not dependent. Everything is independent of the other. So if we have dependent events to visualize the outcomes, we can use a tree diagram and then branch off after each event. So again, more than 2 stages. Or the stages are dependent. Those are when we'll use a tree diagram to identify the sample space, to visualize that information. So we start off with the experiment and we flip a coin 3 times. So the first time we flip it, we have these 2 options, heads or tails. After that, we do it again. So we still have the same 2 options, heads or tails. It just the sample space is going to determine, do we get heads first or tails first? So then we look at it a third flip, again, have the same two options. Okay, we'll finish up when we get back to lunch. So again, listing them out in the order that they occur. So on B, get that one started. So again, we have the coin toss to start. So we can get heads or tails, but from there, we're going to roll a die. Depending on if it was heads, 4 sides. If it was tails, 6 sides. So then our sample space would be that. All right, so looking at part C. You're planning to go a hike with some of your friends. You have 3 trails to consider: Abel, Boral, and Condorcet. I don't know. One of your friends, Jess, requires a wheelchair. If she joined you, the group couldn't handle the rocky Condorcet trail. So, what is the limiting factor on the trails? If Jess is with you or not. So that's where you start. So if Jess is with you versus not, then what you can do after that. So go with the most limiting factor first, and then start listing your outcomes. So we can only do these 2 trails if we have Jess. We can do all 3 trails if she's not with us. So those would be your options. All right. So the last one, you have a modified deck of cards containing only the Jack, Queen, King. You draw 2 cards without replacing them. It matters which card you pick first versus the other. So with that in mind, what are your options? You should have 6 items in your sample space. Since we're all dealing with one suit, you don't necessarily have to have the hearts on there. I would be fine with that. If you're dealing with more than one suit, then you would need to have the symbol or something as a subscript to identify what it is. So first, you can pick one of those 3 cards. So if you pick the Jack first, what does it leave you to pick from next? So you're left with only the Queen and King to pick from, the Jack and King from there, and the Jack and Queen here. So then our sample space. So your homework is listing things, independent, dependent, sample spaces, all the different pieces of information. So